Welcome students.
We are excited to announce our free online classes for placement preparation, GATE and NPTEL courses.
Friends, we are starting one special series. So this is for the computer science and engineering, total 333 topics, notes, and if you will cover the total 333 notes, then 100% your GATE syllabus for CSE, IIT and data science we will complete. Okay, and second one, this is very good for the placement, and third one, we will complete the whole BTech all courses. Okay, we will cover all the subject. If you are learning only these 333 topics, your entire BTech complete, even also MTech also and research also. And at last, the fourth one, the net CSE also easily you can crack. So now we are coming here. Today is a this lecture. This is the first lecture we are starting from here. So this lecture is the disk scheduling. This lecture is the disk scheduling algorithm. Okay, this is the first lecture, total 333. So to manage read and write request of a computer hard disk drive, means HDD hard disk drive, and or solid state drive SSD is called the disk scheduling algorithm. Now actually what is our goal? Our goal to reduce the seek time, number first. Okay, so here are many important or most commonly used disk scheduling algorithm. These are number first come first serve, and second one SSTF, shortest seek time first. Third one is scan, C scan, loop, C loop, and random disk scheduling and LIFO. So one by one we will discuss, and we will also show such type of questions are coming in your placement in GATE exam, NET exam and your semester end exam. So maybe this is according to your BTech syllabus, this is for the operating system, but if you have good knowledge computer organization, so this is also very important for the computer organization according to the IIT syllabus. Now we are coming here, placement problem. This is very important. Now number first, what is the definition of operating system? First question. So you have to remember, operating system is a platform to execute all application. Okay, you have to remember, operating system is a platform to execute all applications. Question, what is application? Now see here, I will show what is application. There are some. So what is the application? Now see here, this is our device. You can see there are many applications. These are applications: PowerPoint, YouTube, File Manager, Outlook, and Gmail, Map, Clock, or any different type of apps you call apps. These are the applications. So these applications are working only because of the operating system. Okay, so now there are many different type of operating system if we'll study. So the first operating system was GMNAA. Okay, this was the first GMNAA, input output, and it was developed in 1956. This is only for the actually research purpose. Okay, and North American Aviation, it was developed for IBM 704, and this was the batch processing system at first, and later the first operating system it was launched for the high level language. It was B500. Okay, I am writing here B5000. Okay, now after then many other language, you can see Unix came. Okay, so Unix 1969 developed by Ken Thompson and Dennis Ritchie, and after then you are using also your personal computer operating system. It was developed by Gray Kildall, and similarly other operating system, Microsoft Windows 1981. Okay, it was developed by Bill Gates and Paul Allen. So initially it was the famous operating system was MS-DOS. Okay, and after then Windows XP, and nowadays Windows 11, Windows 12, Windows 13. Okay, and for the Mac operating system, it was launched in 1984 under the leadership of this Steve Jobs. He introduced the graphical user interface, and Linux, it was came 1991. So Linus Torvalds created Linux kernel, and you know that it is currently dominant for the servers and supercomputers and the for the foundation of Android. Nowadays many people they are using the mobile phone. In the mobile phone, Android 16, Android 17, these are the latest operating system. Okay, so if you'll see, so operating system, what I told, Microsoft Windows and MS-DOS, Windows XP, Windows 10, Windows 11, these are the famous Windows desktop based operating system. Mac OS, this is for the Apple. Linux, this is for if you are working in any organization, then you are using the Linux. Okay, and similarly there are different type of operating system. So now I will go to the next topic. So you can see that such type of questions are coming in your GATE exam CSE 2020. This question came. Similarly this question came NET 2026, and similarly after completing this lecture, okay, if you listen the lecture, then after then you can solve these questions easily. Okay, these questions are very easy. This question came ISRO CSE 2018, and this quiz came in GATE CSE 2018, and this question came in ISRO CSE 2017, and this question came in UGC NET CS 2017. So we cannot show all the questions one by one. Okay, so we will start from here. So now the first question, this was the first disk scheduling algorithm. It was named FCFS, disk scheduling. So what is the meaning of this? The requests are proceed in order they arrive. Okay, so when you are going to the bank, so in which order you arrive inside the bank, according to this they also proceed your task. Okay, so they finish your task or they execute you. Okay, so now this is the first come first serve. So there is example, this is the request sequence and this is the head position. So there are the sequences 176, 79, 34, 60, 92, 11, 41 and 114. I am writing one example. So after solving this such type of questions, you can solve any question. Okay, so now at first I have written all these numbers in this line. Okay, now I started from here 50. So first I got 176. So at first you have to proceed 176 or you have to execute 176. After then next turn for the 79. So you will execute or you will proceed 79, and after then next 34. Okay, next 60, then next 72. Okay, and 92. This is 92. Then after then 11. Next you will execute 11. Similarly you will execute one by one, and after then you have to find the distance from here to here, 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 distance from here to here. So at last you will get total head movement. Okay, so how many head movements are there? Now see here how many head movements. Total number of head movements are 510 if you will calculate. So here the time complexity is order of n. So in which order the data is coming. Okay, so you are executing each and every one. Okay, so time complexity is order of n. Now this algorithm has no starvation. Okay, The algorithm looks, this is very good and there is no starvation, and this is very fair also, but generally this is not good. Why? This is not good. Why this is not good? I will show one example why this algorithm is not good. Now see here, I have written one very simple example. So the simple example is here. I will show here. So now see here, this is example. Here you can see, suppose I have 1 in my sequence is 1, then after then 199, then after then 70, then after then 198, 60, 195 and 2. Suppose I start from the head position. Suppose my head again 50. So the first data was 1. So 100% at first you will execute this 1. At first you will execute this 1. Okay, at first you will execute 1. After then next what you will execute? At first you execute 1. So now next, at first you execute 1. Next is 199. I will execute 199. Okay, next turn is this. Third, I will execute 70. So where is 70? 70 is here. I will execute 70. Okay. Next, I will execute 198. I will execute 198. Next, I will execute 60. So 60 may be somewhere here. Okay. So next, I will execute 60. Now after then next, I will execute 195. I will execute 195. I will proceed 195. You can see. Now here you can see. At last, I will proceed 2. So now think, when my disk was here at 1, so definitely 2 is very close to 1. I should execute 2, but according to the FCFS, the turn 2 turn is coming after a long time. And suppose there are infinite data, suppose in between there are infinite data, and all data greater than 2. So in this condition, if all the data are greater than 2, in this condition 2 is facing starvation. If you will see, 2 is facing starvation. Getting? So time complexity is an okay, but suppose there is a infinite, means not infinite, in disk is not infinite, okay, but suppose there is a all the data here in between, all the data are greater than 2. In this condition, after 1, the 2 turn is coming after a long time, means seek time is increasing. Okay, this is the problem in FCFS. So the scientists, they discovered another algorithm. The algorithm name was, so the algorithm name was SSTF. Okay, the algorithm name was SSTF. So now see here in SSTF, this is the shortest seek time scheduling. So now this disk scheduling algorithm select the request that is closest to the current position of the disk head. Now same questions we are taking again, and head also 50. I will show what is the meaning of closest. Here many students, they are doing mistake during the competitive exam as well as in your semester exam. Okay, so I have written this question in a different page. I will show what is the meaning of closest. Now see here, same question here. So my data is 176. Okay, you have to note it. Okay, then next is 79, next is 34, next is 60, next is 92, next is 11, next is 41, and next is 114. My head is 50. My head is 50. I am writing here mod actually. Why? Because distance always positive. So head minus this value I will subtract. So 50 minus 176, next 50 minus 79, next 50 minus 34, next 50 minus 60, next 50 minus 92, next 50 minus 11, next 50 minus 41, next 50 minus 114. Okay, so now I will check which one is the smallest. Now you can see among this 126, 29, 16, 10, 42, 39, 9 and 64. This 9 is the smallest. So it means that 41 is the closest to 50 among this data. Okay, so 50 is very closest to 50. So 41 is very close to 50. So now my next move is 41 again. So after then, from this stack I have selected 41, so I will remove 41 from here. Done. This is my stack. I remove the data 41 from here. Okay, now this is also data structure actually. Now next I will take 41 and I will subtract remaining element. 41 minus 176, 41 minus 79, 41 minus 34, 41 minus 60, 41 minus 92, 41 minus 11, 41 minus 114. So 7 is the smallest, so next data is equal to 34. What is the meaning of this? My next head is 34, so 34 is the closest to 41. Now I will remove this 34 from here. Now you can see initially there was total number of n comparison. After then one data I removed, total comparison are n minus 1. So now I removed 2 data. From here I removed 2 data. So next time total comparison will be n minus 2. Now see here. So my next data is equal to 34. Next head is 34. So 34 minus remaining element 176, 34 minus 79, 34 minus 60, 34 minus 92, 34 minus 11, 34 minus 114. So the smallest element is smallest outcome is 23. So my next head is 11, that is very close to 34. So what is the meaning of this? I will remove this 34 from the stack. Already I removed. Okay, now my next is 11. Next is 11. So 11 also I will remove from here. Okay, so total comparison are now n minus 3, because I removed 3 element. Now 11 minus 176, 11 minus 79, remaining element 11 minus 60, 11 minus 92, 11 minus 114, and next smallest element among this is 49. So my next head is 60, that is very close to 11. Okay, similarly so I will remove this 60 from here. I will remove this 60 from here. Okay, so total data are now n minus 4. Total comparison are n minus 4. So total comparison are n minus 4. Again 60 minus 176, 60 minus 79, 60 minus 92, 60 minus 114. Smallest is 19. So my next head is 79. 79 is very close to 60. So now I will remove the 79 from the stack. So 79 minus 176, 79 minus 92, 79 minus 114. Smallest is 13. Next head is 92. I will remove the 92 from the stack. Now next 92 minus 176, 92 minus 114. Smallest is 22. Next head is 114, and at last I will delete also this one. So and I reached to the end position. So if I will check the time complexity, time complexity n plus comparison n minus 1, next comparison n minus 2, up to so on 1. So what is this? Sum of the natural number 1 plus 2 plus 3 plus 4 up to so on 10. So what is the meaning of this? What is the sum of natural number? N into n plus 1 upon 2. You can check also, sum of 10 natural number is equal to 10, and you can calculate also if I am wrong. Okay, so upon 2, so this value is equal to 11 5 is 55. Okay, so sum of the 10 natural number is 10. So the formula is this. So it means that if you will calculate, time complexity is order of n square. Okay, in the worst case, time complexity order of n square for this algorithm. For this every algorithm, the first one has time complexity order of n and other has. So like this the algorithm is working. You have to understand this algorithm. This is very important. So now you can see my first was 50, and next was the closest. After then the closest was this. Then after the next closest, next closest, next close, next close, next close, next close, next close, like this. At last I reached my 176. So after then you will find the distance from here to here. Okay, the distance from here to here. So at last total head movement is equal to 204. Total head movement is equal to 204. If you have any issue, you can see my first movement is equal to 41. I will check here also I am correct or wrong. Okay, I will show you. So you can see close to 41. First was 41, second was 34. Okay, if you have any issue, 41 and 34 you can see also here. And this first one was 41, then 34, then after then 11. Okay, so it is very easy. If you understand this algorithm, next algorithm is very simple.
Our mission is to help students achieve academic and professional success.
We will guide you step by step with high-quality learning resources and practical problem solving.
So now this is a IIT question. What is the IIT question? What they asked? What is the time complexity? Time complexity order of n square. Why? We explain. Second question they asked about the SSTF guarantee the absolute shortest total seek time for the sequence of requests. No, because SSTF is based on the greedy algorithm. This question they asked in IIT interview. This is the greedy algorithm. Okay, and later we will discuss about the look and see scan. Okay, here I will not discuss, later we will discuss. Now next question is the scan. So scanning means scan everything. Okay, scanning means scan everything. So what is this? Once I am starting from here, I am going. Now you can see also here what I am doing actually. We are taking the previous algorithm. In scan disk scheduling algorithm, head start from one end. Okay, head start from one end of the disk and move toward the other end. Okay, and serving request in between one by one and reach the other end. What is the problem here? I am reaching to the end position even this is not my request. 0 was not my request, but I am reaching to the end position. This is the problem in scan. Okay, you are reaching to the end position. This is the problem in scan. Means you have to scan everything. Okay, so this is also same problem. Okay, same algorithm, previous algorithm we are using. Again I will not explain. To subtract it one by one. Okay, you have to use the same algorithm. So now you can see, so total head movement is equal to 226 if you will subtract. So there is a this question asked multiple time in your competitive exam. So long wait time for the immediately behind the head. So here scanning also there is a starvation. Okay, there is also a starvation. Already we explained why there is a starvation. So scan and look later we will discuss. Here also time complexity same order of n square, and for the optimization time complexity order of n log n. So now every algorithm time complexity order of n square in worst case except the first algorithm FCFS time complexity order of n. Now C scan circular. What is the meaning of this circular? Circular scan means scheduling algorithm is modified version of the scan. Okay, what is going on here? So here it moves the head from one end serving all the requests to the other end. However, as soon as the head reaches to the other end, it immediately returns to the beginning of the disk without serving any request on the return trip. Okay, whenever you are returning, at that time you will not serve. Okay, time complexity is same order of n square. So now I will show you. See here, I started same question, same head. I started and I am going to the one direction. Okay, I am going to one direction and I serve each and everyone one by one. I serve each and everyone. I serve each and everyone. And after then, when I am returning back my returning trip, I am not serving any request. So again I am reaching but end position. Here also I am reaching to the end position. This is the problem in C scan. In scan and C scan. Scan means scan everything. Okay, scan means scan everything. So you are reaching to the end position. This is the problem. Even there is 0 is not there, but I am reaching to the end position. Again I am serving each and everyone. okay, all the request. So now C scan, you can calculate this value, and if you calculate you will get 385 something. Okay, so C scan, what is the advantage of scan? It's reduce the average seek time, number first, if you will compare with FCFS, and balance, okay, in both direction, okay, serving request in both direction. What scan? But C scan is not serving both direction. C scan is serving only one direction. Okay, then after then returning, there is no request, you are not fulfilling any request. Now it's minimize the starvation. If you will compare with SSTF, in SSTF there is a starvation. This question came in your IIT interview. Okay, what is the disadvantage? I will show you. This is very complex, you can write also. Now see, now next algorithm is look. Look means you are looking. Okay, if there is any request, once you are reaching to the end position, so before reaching, once you are reaching to the end position according to the request, so after then you have you stop. Now in the competitive exam, most time this in net exam as well as in your this semester end exam, this question came. Okay, this at first FCFS, then after then SRTF, then scan, then C scan, then look. Okay, this hierarchical structure they asked multiple time. So time complexity same here also, n log n for the optimization. Okay, and otherwise it is order of n square. So the look algorithm, how it is working, I will show how it is working. I will not explain here, I will explain here. Now see here, I am going to one direction and I am serving each and everyone. I am serving each and everyone. I am serving this, I am serving this. If there is a request, I serve. Okay, so I proceed, or you can say. So once I am reaching this end position, so I am not going to the end position, because after then there is no request. I stop and I am going to the back, and again in back also I am serving. Okay, in back also I proceed each request. This is the meaning of look. Okay, but what is the problem in look and see look? Whenever you are going in one direction, you are proceeding each and every request, number first. Again you are returning, again you are proceeding each and every request. So complexity of this program is increasing. This is a problem. So after then they discovered another algorithm that was better than other. Total head movement is equal to 291. So if we will compare look and see look, after then we will discuss about the see look. Okay, so scan already we discuss, look already we discuss. Now we are discussing about the see look. Why see look is better than other, I will show you. So the see look means circular look. Okay, the C scan is used to avoid starvation. So what is this here? What I am going, if you will see same example, I started from here, I am going one direction, I am going one direction, and I serve each and everyone. I serve each and everyone. So after I am not reaching to the end position because there is no request. This is the last one in this direction. Then I am coming back. So whenever I am returning trip, there is no request. I will never fulfill any request. So in this condition, complexity is decreasing. Program complexity is decreasing. Again I am reaching to the end position. If there is a request, then again I am going to the another direction and I am serving each and everyone. Okay, so this is the benefit, this is the best algorithm. Okay, this is the best algorithm if you compare with other. So C scan is overall best among these other, and total time complexity is also order of n square. Already we explained why it is order of n square. According to the optimization, the time complexity order of n square. Now if you see here, this is the chart we created. The first one FCFS, this is very slow, number first, and this is perfect, there is no starvation. But I saw also, if there is a, but in computer there is no infinite data, but there is a little bit starvation, so this algorithm is not good. Time complexity order of n here. Okay, so time complexity order of n, okay, no problem, but this is very slow. Okay, this is the problem. So after then they discovered another algorithm, SSTF. This is very good, but there is a starvation, high starvation risk. Okay, so this is also not good. Okay, after then they discovered another algorithm, scan, C scan. So what is the problem in scan and C-scan? You are reaching to the end position even there is a no request. So these algorithms are also not good. So after then another algorithm, look and see look. Both algorithms are good, but here complexity is increasing. So the best algorithm is C look. Okay, overall best algorithm is the C look. So now if we'll come here, so C look is generally considered the best and most efficient disk scheduling algorithm among these listed, whatever we explained in this lecture. So this is the overall scenario of this lecture, and next we will discuss another DBMS. Okay, so one by one we will cover each and every topic, and we will also come to the computer organization, another floating point after then. So one by one daily we will give you 2 marks or 5 marks if we will cover all 333 lecture 100% in every competitive exam, your semester end
Join
exam,
our learning community
your
and
GATE
start your
exam,
journey towards
placement,
success.
you will get good
Please
marks.
subscribe to
Thank
the
you so
channel
much.
and press the bell
Okay.
icon to receive
Thank you for
So
watching.
thank you so
See you in
much.
the next class.
class.